tools. Azure Monitor Integration, there are tools. Application insights, that means you are finding out whether the performance is happening as per the required uh, expected level. Log analysis. So there should be a mechanism of analyzing the logs. So there you have heard about SRE. SRE is now becoming very popular. Okay, so this is a system resource engineering. That means this is mostly from the operations team with experts like DevOps who are good in doing SRE. So basically this monitoring and logging. So there is, you have heard the term or the tool called Grafana. Logstash. These are the various tools that will help you with SRE and various log analysis, application insights, and monitoring. All these tools can also be provided by Azure DevOps. Azure DevOps is one application from Microsoft which gives all these tools available to you. You do not need to go for Kibana or having buy the Grafana or Logstash as part of SRE. Everything is inbuilt within the Azure DevOps. So it's a very, very popular tool. And therefore, there is also the how you error handle and provide the notifications. You basically determine the task conditions, retry logic, email notification, and chat integration. So all these chat bots and everything can also be integrated with the pipeline. Your pipeline can throw email notifications to the respective for approval requests and all those stuff. Okay. Error handling. Pipeline security best practices. You have the service connections. So you are getting a service connection to the various external services, but through a very, very secured mechanism. Sorry. And those are given by Azure DevOps only, service connections. So you make, let's say you have GitHub. And here is your Azure DevOps. Okay, and your pipelines are getting created over here. But the pipeline needs to be getting integrated with the GitHub, because your development source code all is over here. So you have to fetch them, integrate on the pipeline. So what you need to get a secured connection. So all this is called the service connection. And this is very secured because it is provided by Azure DevOps. So, and it is very simple to get this service connection established between the Azure DevOps pipeline and the GitHub. It can be Docker Hub. It can be any other external like Azure, Nexus for the repository. Instead of using the Azure repository, you can use Nexus. So there will be a service connection with the pipeline to integrate with Nexus. Like you have Terraform, which is external to Azure DevOps, you will have a service connection to Terraform. And as long as the service connection is working, you can easily integrate Terraform and Terraform services over onto this pipeline. Is that clear?
Yes, sir.
Yes. And basically, these are all secure coding practices. These are all enabled within your pipeline. I mean, Azure DevOps. Access control. These are, you see, these are the modern way of giving access. So you should be aware that there can be hackers, there can be so much of issues. So you must go by the standard principles or standard practices. You do not need to worry too much because these are all inbuilt services that are provided by Azure DevOps. So protect your main pipeline configuration files with branch policies requiring code reviews and build validations. Consider using environment approvals for production deployments and limit who can override failed checks. So all these configurations you can do over the pipeline. Like as I was saying that you can integrate with the external tools. How? With those service connections. So that is a GitHub integration. Connect Azure pipelines to GitHub repositories to build and deploy code stored on the GitHub while leveraging Azure DevOps powerful CI/CD capabilities. This integration supports triggers from pushes, pull requests, and even GitHub Actions workflows. Even the webhooks can be integrated over onto the pipeline through the service connections. Jenkins. Jenkins is another pipeline. So you have, let's say, you have a build pipeline on. It is a very weird combination, but let's say you can also do that. That is to say, a build pipeline on Azure DevOps and a release pipeline, though Jenkins doesn't have a release pipeline, but I'm saying just an example, or some of the activities on a pipeline given by Jenkins. Maybe Jenkins is good in that. So you took that from Jenkins and integrate Jenkins with Azure DevOps pipeline through this. So incorporate existing Jenkins job into your Azure DevOps pipeline using Jenkins task. See, again, the task came into the picture. The task, you just have to call the Jenkins task and the integration will be done automatically. Container registries. So you can integrate with Docker Hub. As I was saying, Docker Hub is a place where you can have all your images stored. We have understood that in our Docker session. So this is an external tool, but you can easily integrate with the service connections and whatever. So see, for pipelines, these are the you see these are the pipeline script, a simple pipeline script. As I said that this you have organization that is on the top of the sea. This is, if this is a pyramid, so on the top of the pyramid lies what? Organization. You cannot start a project without an organization. So on below the organization lies what? Anyone? On the topmost is the organization, is the project. Without a project, you cannot create a pipeline. And then in the pipeline, let's say this is the pipeline. pipeline. And within the pipeline also there is a hierarchy. So there is, first is the stage. What will come after stage? Within the stage, you can have jobs. You can have job, one job or multiple jobs. And within each job, what is there? Finally, the work is there. Task. Very good. Final intention is to build the task within the job and within the stage. So stage, job, task, and there you write all those tasks that you want to do. And while doing the jobs, the jobs can be sequential. So this is job 1. Then the pipeline goes to job 2. Once the job 1 is complete, it goes to execute job 2. If the job 2 is complete, it goes to execute job 3. This is sequential. And then within the stage, so this is stage, job 1, job 2, job 3. Another can be the same stage. You can organize the job as job 1, job 2, job 3. So you see at the same point, all the 3 jobs starts together. So these are called parallel jobs. So they are starting together, not sequential. This job does not depend on this job for the completion. Okay, or to start this job, I do not need the job 1 to complete. They will start together. Maybe this job will have again a sequential job 4. Then job, so they are not parallel. So job 3 will complete, will start job 4. Job 4 will complete, start job 5. But job 3, job 2 and job 1 can start together. Is that clear? So here you define the clause as jobs. This is the JSON key. Because you are writing YAML. And this is a sub key and a value. You see, key : value. So this is another within the job. This is called parallel. These 2 jobs are parallel. These jobs are running in parallel. What is the job name? The job name is build frontend. And this job name is build backend. But they start together. So the tasks will follow the job. And then you say steps on the tasks. Basically say steps and you write a script. That is, you are saying the npm build. So you are building the backend, not the backend. I mean, for say React.js or React Native or Angular or Vue. So all the front ends which will run, but you have to build the Node.js engine first. So you will do an npm build. So very simple. And for the backend, let's say backend is provided by Microsoft.NET. Okay, so this job will parallelly start .NET build, npm build, and .NET build. So this front end for React, Angular, Vue, and for the build backend, so .NET applications using the .NET build. Anyway, that is besides the point. And this is a matrix strategy. So it depends on your strategy. This is parallel job strategy. You say, here I have a job by the name test, but I have a strategy within the job. And can you see that they are working on the same level? So this job has a strategy called matrix. So the matrix is like, what is your operating system? If it is Windows, then the OS being used is Windows latest. And the framework is whatever the framework. Linux, if you are using a Linux matrix, then the OS you are using may be Ubuntu. It can be Red Hat latest. Let's say I'm using Ubuntu. But if it is Mac OS, can you see Mac OS? You are using Mac OS latest. So depending on your platform or a matrix, so the strategy is to use this particular operating system depending on your platform. And the pull. Pull is nothing but, the pull is nothing but your VMs or virtual machines that you are going to use, or the servers, the virtual servers. And this virtual server is provided by, this server is provided by whom? If it is not hosted by you. If it is not, there are two things. Self-hosted servers or Microsoft hosted servers. So this, whatever it is, called pool of servers. Now here I am using, whenever I'm saying VM image, I am basically using a Microsoft's hosted server. And that hosted server is using $OS. Now, can anybody tell me which OS I'm going to use? What is that $OS? It is basically the matrix. It follows that matrix strategy. So if my framework, if suppose my software is deployed over Windows, then the OS is Windows latest. If it is on Linux, it will be Ubuntu. If it is on Mac OS, so it is asking Microsoft to host a server depending on the OS or the platform, that is based on this strategy. And after it has been determined which is the OS, we will go to do the steps directly. That means I have no jobs. So my job is one job. It is only one job. Under this, I'm making a strategy, and therefore I'm using the task or the steps to doing some test. This is the variable and the extrapolation of this variable with a $sign. Framework is the variable. So net 6.0. So that is the framework that we are using. And you are going to do the test on the image or the VM image, virtual machine image, which is a Microsoft hosted server. Any question? Artifact management is not important. Infrastructure as a code, now we have already understood. Everything is like so you version control is a GitHub. GitHub is also something which stores your code with a version managed. You will define the infrastructure. So what can you do with? So you can do it with Terraform. This is GitHub. This is Terraform. Test templates for errors and best practices. So validate. So you can have many testing tools over here. And finally, you deploy it over the provision the resources automatically. So everywhere. So here it is the pipeline. Everywhere you can code through the scripts. Simple. So here it is pipeline, Azure DevOps pipeline. So test codes like on is scripts on the Selenium test bed, Terraform, and this is GitHub. Okay. Infrastructure as a code allows you to manage your infrastructure using configuration files rather than manual processes. Azure DevOps supports multiple IAC approaches, including ARM templates for Azure specific. So don't go about all these things. That is too advanced to understand or explore at this stage. We'll skip this. So container-based CI/CD, whenever you are saying that you want to do the entire deployment based on containers, then you follow this path. You container file or a Docker file or a Docker compose, as we discussed. Docker compose is a utility or a tool coming from Docker. So the container build instructions, you put it into that file, Docker compose or Docker file. It will build your image and put it into the container. So therefore, the packaged applications and dependencies. So you build the Docker images out of the Docker compose or Docker file. So Azure container instances. So serverless container hosting for simple workloads. This is where your pipeline integration comes into picture and does the services. You remember that those services and tasks that is inbuilt within Azure DevOps that will help you to serverless, because you are not worried about which server you are getting hosted. So the container hosting happens serverless to you. Okay. And finally, you deploy it over the Kubernetes. Orchestrated container management for scalable applications. So these Docker files or the Docker images will need to be deployed on a containerized or orchestrated container management for scalable. So for scalable applications like enterprise level applications, where it has to be scalable. That means today there are 1,000 users. Tomorrow, after a year, it can be 1 million users. 1 million users. So your application should be able to cater to 1,000 users very simply, and also with the same performance for 1 million users. There will be no performance degradation. That is called scalable application or enterprise level applications. So for that, you cannot sustain with an application which cannot scale up itself with all the security features, monitoring features, and everything. So we need to have it deployed over this thing. Any questions up to this point? So if you can deploy your applications over CI/CD, you can also deploy your database. Yes, you need some like the data tier application data package. This is already inbuilt within the CI/CD. I mean the Azure DevOps. So this sort of packages will help you, or tasks will help you build your database applications build process. Okay. Strategies, testing strategies in CI/CD, automated UI testing, security testing, load and performance testing, chaos engineering. All these are strategies, various strategies of testing. So chaos engineering, deliberately introduce failures to test your system resilience. How much resilient is your system? You introduce errors, bugs inside the system and check whether your system can still sustain. Suppose you suddenly make your network heavily loaded, okay, or you enables few services going down, make some resource constraints, and then you can verify that your application gracefully handles unexpected conditions and maintains reliability. These are various types of testing strategies. Load and performance testing. You have to do the security testing and user interface testing automated. You would be using tools like Selenium, Cypress, Playwright. Selenium being the most popular. There are lots of things in Azure DevOps. Okay. Is anybody there?
Yes, sir, there.
Okay. Fine.
Yes, we are.
Uh, I just can show you the interface. There is not much of time to explore anything much more than that. So you can see that the interface. I just can go there and check the interface. So let's say this is where you will be. See, there are two parts. One is the Azure portal, which is the Azure cloud, Microsoft cloud. And within the Azure cloud, there is the Azure DevOps, or you can go separately to Azure DevOps if you have your Azure account. Azure account helps to once the Azure account is created with some policy, you can explore all the Azure tools within the Azure cloud. One of them is Azure DevOps. So when you log into your Azure portal, this is the Azure portal, portal.azure.com. So you see, these are various, there are much more services, out of which one is the Azure DevOps. You can click on this and you can go into, because you have already logged into Azure portal, you have the Azure DevOps is a subset of a tool. And I have an organization called Debasis Kalkey. I am going to that organization. So I am there in Debasis Kalkey, and these are the various projects, because you have seen that the architecture, the hierarchy. Organization uh, is on the top of the pyramid, followed by your project, followed by your pipeline, followed by within the pipeline elements like your stages, jobs, strategy, jobs, uh, and the steps. So for an example, here you see this is your Azure DevOps. You have logged into your Azure DevOps and you have created your project. There are 3 projects over just for an example I have created. You can create your new organization. and you can embed or uh, configure the organization policies, configure organizations for lots of organizational settings that you want to do, and then come to create a project within the organization for hosting this particular project. So let me go into one of the projects. So you are into your Azure DevOps project. Okay, you create a project. I do not have a time to show you from the scratch, but it is in our regular classes. We explore each and every bit of details. So on the left hand side, you can see there is, as I told you, these are the various tools available under the Azure DevOps. One is the Azure boards. It is like the Jira board. Jira is a project management tool. Similarly, within the Azure DevOps, you have all the project management tools that is needed to manage your project. Okay, like the Azure boards. You can create sprints, you can create your backlogs, delivery plans, everything can be done. So on the boards you can, and there is the Repos. Repos is similar to having GitHub. Within the Azure DevOps itself, you do not need to go outside. You can store all the resource codes or the development codes or resources within Azure Repos. It is exactly similar to the concept of Git and GitHub. Nothing is different. So it is as if the GitHub resides within the Azure DevOps in form of repos. Then the main thing is the pipeline. And if you can select, there is the project settings, or rather the organizational settings, you can have two types of pipelines. One is by default, there is only the build pipeline. But if you can uh, do the project setting for having a release pipeline, okay, so you can, so here I have already configured my project having a build pipeline as well as release pipeline. There are two pipelines, build pipelines only having the name as pipelines is a build pipeline. And if something you see as releases, that means you also can design your release pipeline. So if you click on pipelines, and I have, just for an example, I have a few pipelines. All these are all build pipelines. Okay, if I go to the first pipeline or just a pipeline, and if see, I have created a pipeline. So these are the various runs on that pipeline that has happened. Only 3 runs have happened. But I want to check the pipeline. Okay, I can go and see the edit. Since my connection is not yet established, I mean, it is an old thing. I can revive the connection, whatever it is. Right now, it is not finding. So basically, this is the YAML pipeline. And if you want to go to this is, I have integrated GitHub into the Azure pipelines. You remember, we can have the service connections. So this service connection is part of the configuration that you do with the environment. Okay. I have created a connection to my GitHub. So this is the GitHub. You see, this is the logo of the GitHub, and my GitHub account is Debasis-Jiv. And there I have created a repository called DSA43 or whatever, Azure DevOps project 1. And over here I have created. So see, here I am not finding the code, but okay, that's fine because the service connection is not active. So I can directly go to my GitHub. See, I am there in my GitHub. This is my account. This is my account. and I can go back. This is my repository, that one repository. And here is my Azure 01 first Azure Pipelines YAML. You can just click on this and you can see that. Can you see the code? You are saying that the pipeline will be triggered when there is any activity on the master branch. Any changes that the developer puts any changes onto the master branch of that repository. So immediately the pipeline will be triggered. Which pipeline? The pipeline is 01 first Azure pipeline. It will be triggered. It will be run. And what is the pull that I'm using? I am not using the VM image. I've made a comment. Can you see? What does that mean? Can anybody tell me? I've commented out the VM image. What does that mean? That means I am not using the Microsoft hosted agents. I'm not taking help from Microsoft for the server. I have created my agent myself. This is an individually hosted or self-hosted agent by the name. So this has been created. There is a mechanism to create that agent. And in that agent, I have installed maybe Terraform or this and that. Basically, I have to do a lot of things installation because that is my customization that I'm doing onto my server, my individually hosted agent. Whereas if I had used the VM agent, VM image, I would have used the Microsoft hosted in this. This is the OS Ubuntu, and whatever necessary softwares you name it, everything will be available there. Terraform, Ansible, Docker. I do not need to install it separately. Unlike my self-hosted agent. My self-hosted agent, I do not have anything. I will have to install them. Only whenever I was creating this hosted agent, I had mentioned which OS, whether it's Ubuntu or Windows or Mac. That much is there, but the rest, nothing like no Terraform will be available, no Ansible will be available, no Docker will be available. I have to do it separately. Whereas if I had used VM image, I would have got everything ready-made. So the jobs, I do not have any strategy. That means whatever is inbuilt within I have built within the hosted agent will be used as my strategy, whatever the platform. And so I start directly with the job. So you see, this is the parallel jobs. Job, first job, second job will run in parallel, third job will run in parallel, fourth job will run in parallel. But at the same time, I have, see, this will start, the first job will be started automatically with these steps. So I'm doing some echo, very simple. So display name. So what will be displayed as a job? So that will be just run one line script. So that will be just name of that particular step. And here is the echo first job, hello world. So this will be displayed on the screen. When you run this pipeline, you will see all these things happening. Simple echo command. You see, this is a Linux command. Echo. I'm kept it very simple. And this will be shown you as that the script or the step is doing this particular run a multiple line script. First, it will run a one line script. It will be in the debug log. It will be displayed. Second job. But here I have used a clause called depends on. How does it change then? Will it be a parallel job or will it be a sequential job?
Sequential job.
Sequential, because it has a dependency you have been built with the first job. So unless and until the first job is completed, it will not start the second job. So it is a sequential job. by using just a simple thing called depends on. That is how simple it is. Third job. Now, this second job and third job will start parallelly once first job is completed. Why? Because the third job is also depends on first job. So immediately after the first job is completed, the second job and third job will start running parallelly. And then the fourth job. Fourth job has a dependency on second job as well as third job. So unless and until the second and the third job has completed, fourth job will never start running. So if I visualize this, see how simple it is. So when I visualize this, how shall I say? So this is the jobs. Okay. Which one will start first?
First job.
First job. Whatever the job name is, first underscore job, I think. It will start. If it completes, so now it completes. It will start
Second job and third job.
second job on the same line, on the same level, because they are parallel. The third job. Same time. Okay. And now both completes. Only one completed will not do. One completed will not do. It has to wait for the both the jobs to complete, then only it will start the fourth job. So you can have a hierarchy based on whatever design that you see, but it is so simple. Within the first job, what are the steps? It will just execute the tasks as a script. Script is one of the modules through which it will execute. So script is a shell script. So it is a shell command. You see echo. Or if you say script, if you want to run a Terraform job, what is that? You say Terraform. This is the shell command, Terraform validate or Terraform plan. So echo that is, and then you say script. Here, let's say in the fourth job, you want to do the Terraform apply auto. So basically, I'm writing the shell command for Terraform, which is Terraform CLI, Terraform apply auto approve. But actually, you are doing it through a task, which is script under the steps. So it will execute. But so to get this thing executed, what is my task? I will include a task from Terraform. I will show that. After that, we can take a we can end the session. See. So I go back. This is my GitHub. So I was showing you the code, the pipeline. This is YAML file. Okay, by the name 01 first Azure pipeline.yaml. I can copy this and put it over in my. So you can copy that entire thing because you have done it and just paste it over here. So and then you can save it and run it. It will run. Can you see on the task? So let's say I'm trying to get a Terraform task. Can you see Terraform, Terraform CLI, Terraform installer, Terraform tool installer? Maybe I do not, I have to have a service connection to Terraform. But here, you see, I am giving the provider. Let's say I have a provider called AWS, not GCP or Azure. Azure RM is the Azure cloud. AWS is Amazon cloud. GCP is Google cloud. Okay, so I am taking AWS. I am saying which command that you want. I am saying that I want the Terraform apply command. And you can use apply. And let's say the configuration directory is the default working directory of the system. So command arguments, you can say auto approve. This is the command argument. And if you say, I do not have a service connection right now, so no results found. But if you had a service, I will build a service connection to Terraform. That is a different topic. But then you add it. Can you see that there is under the, because I do not have a service connection to Terraform, it is giving some underline of something. Okay. And this task does not have some, you see, this task does not have any precursor. That means how suddenly we can start with a task. We are not maintaining the hierarchy. So where will the task come from? The task will be under the steps of jobs. So the jobs, you name a particular job, or you just start with the steps. If you have only one job, start with the steps. Within the step, you have the task. So it is, see how simple. Your command is apply, a Terraform apply. Whenever you execute this, you see, you can save this. And whenever you execute it, it will go to the service connection to connect to Terraform, and then use the AWS CLI to connect to the Terraform. And the Terraform will connect to the AWS cloud and do this apply, because on the Terraform, you have the Terraform scripts, which will apply from the root directory of Terraform, or whatever the project directory of Terraform that you have created, it will. So all these things are part of the pipeline script. But how easily I could create a task of Terraform apply? Can you see? Because I have discussed Terraform, that's why I'm giving this example. Is it okay?
Yes, sir.
So thereafter, you will say, you will save, and then you can run it. And if you run it, you will see, I will say leave, because I don't want to save it. I do not have the VM image, or nothing is there, so it cannot work. But you see, you can create a new pipeline, or you can select this pipeline and you can run the pipeline. You can go and check what happened into this. So this was the job. So it started the first job, second job, third job, fourth job, and successfully done. So you can go to first job. You can check the log. I think it was built quite long back. 26th of March. So it was long. So it is not finding all the relevant links and this thing, but let's see what it comes up with. So the first job, you can view the role, and now there is nothing is there in that. You see, uh, these are what is happening. Can you see that? Uh, this is the raw log file. That is what is happening behind the scene when you have called this particular simple job. So the task is the command line and echo. Can you see? First job, hello, world changed. So that was part of the script that you have executed. So first job, hello, world changed. So all these things. So get the sources, what all the repository, the Git repository was the Git. So everything was run and it is showing you the log. Okay. So that way you design the, I could not show you the release pipeline there because the release pipeline is not yet been created. And there is our students have done a capstone project. You see, this is was a huge project, very good with Kubernetes, Terraform, Ansible, so many things included. So you can check the pipelines. Kubernetes cluster IAC pipeline. And you can go. I don't think it will be there. Uh, yeah, it is C. There are lots of C. Can you see the task? Can you see the task? AWS init.
Yes.
So Terraform init, then Terraform apply. And finally, it will destroy the EKS cluster. So basically, it is using the EKS cluster on the apply. So there is, and can you see the service name? AWS. I have given a service. But basically, I have configured Terraform, integrated Terraform with AWS over this pipeline. Backend AWS key, Kubernetes dev state. This is the TF state. This is the bucket name where all your state is saved, restored. And the backend service is the same service, AWS for Terraform. So lots of things can be done. See, this is the Docker push, pipelines, build and push the Docker image. All these stages are there. You can go to the edit. You see, I'm using Docker and the tag that I've used is the build ID. I'm copying the file. So whatever, can you see everything is like a task. Task is what I'm getting on the right hand side. So for each of these tasks, I have the inbuilt. So basically, I have nothing to do. Everything is there for me to do. So when I say download the pipeline artifacts, I mean, you have seen that you have stored the artifacts, and now for deployment, you will be fetching those artifacts from a particular repository, artifactory. And then you are doing the Kubernetes, you are executing the manifest file of Kubernetes. You are using the deploy action. You have a Kubernetes service connection type. And thereafter, you are actually you are executing a manifest file to use the EKS cluster, Elastic Kubernetes Service over the AWS. And using that, Terraform is building that Kubernetes cluster over the EKS, and then you are using the Docker images to deploy over that Kubernetes cluster. Is that fine? It's a whole lot of project. It's a big project, but we have to know. But this is overall what you do in a CI/CD pipeline of Azure DevOps. Is that fine? I will just end the session today. I know it is very short time to say so a lot of things over the Azure pipeline. So better I will stop the discussion, stop the sharing, as well as I will stop the recording. So thank you very much. I am not sure whether I will be available in the following weekend because I have some marriage ceremony to attend, but let's see. So thank you very much for your patience. For actually, this is on a Saturday evening. It is very difficult to concentrate, but yes, thank you for all your hard effort.
Thank you, sir.
Thank you.
sir.
Thank you. Thank you. Hello, Shubro. Can you stop the live streaming? Okay, I will take a leave now. Thank you. Thank you, Ernest.